Today we are going to talk about motion. So what is motion? When any object or a particle moves in any direction, that phenomena is called as motion. So a particle will either be in rest or it will be in motion, either of these two states. So how do we figure out the different characteristics about motion? Either the particle will move in a straight line uniformly in a particular direction. So that is a linear motion. Or it can go round in a circular motion or in any form of curve, so to say. So these are non-uniform motions. These are uniform and either linear or circular motion. So when we talk about motion, we also need to talk about a few other things, like what is the distance covered, how much time it has taken to cover such a distance, and so on and so forth. So what is distance? Distance is, let's say a particle started its initial position A, it started moving and it finally ended at B. So if we do not care about which path it had taken, but we just care about what was the initial and the final position of the particle, we are interested in what is the displacement of the particle through space. So the particle was at A and now it is at B. So it has moved from A to B. When we say A to B, let's translate that English statement into mathematical form. So it is moving from A towards B. The arrowhead signifies that. So A to B is called displacement. Whereas the particle might have traveled in different paths and might have actually traveled different distances. So if we just say that it has traveled from A to B, AB is the displacement and the rate of displacement will be AB divided by the time taken. We will come back to the concept of how do we define the time taken. And if we are interested about knowing which path it has taken, then let's say from A to B, depending on different circumstances and different options of path that it has chosen, it has covered a distance of d, but yeah, the time is still remain the same, d by t. So d by t and ab by t, these are two different quantities in maths, because irrespective of what d is, a and b are two fixed points. Hence the displacement will always remain the same, but the distance can be different. So when we measure distance by time, we name it with a particular variable, let's say s. S stands for speed. And when we talk about displacement divided by time, we call it v, or let's say, I give you the full form, it is velocity. As you can see, velocity is a vector quantity because it has a direction associated with it from A towards B. Speed is a scalar quantity. Speed, d is just a number. It does not talk about which direction it has moved in. At any point during its motion where it was facing, whether at this point, let's say if it went from A to B via this path, at some point of time it was directing, or it was looking at this, some point of time it was heading towards this, at some moment it was heading towards this, and so on. So these are all the tangents on the path. So we are not bothered about any of these. We just bothered about from A to B, and let's say it kept on moving some more and then finally came to B. So speed is a scalar quantity. V, vector, velocity, it's a vector quantity. Now if the particle has traveled from A and reached back at A. So we started from our home in the morning, we went to a school, later we went to some other places, and then at the night we came back at home. So from morning till night, if we figure out what our position was, the initial and the final position, both of those are A, or we start from our home and we come back at our home. So in that case, what is the displacement? Because we were at A and we ended at A. So our vector AB is nothing but AA. A and A, these are two superimposing points, the same point. So basically, displacement is 0. So that means no matter how much we traveled, our velocity is 0 by time, whatever time it has taken, that is 0. Whereas, let's say if we travel by a car, so our car would have shown the odometer how much distance we have traveled through this path in the entire day. And let's say that is 25 kilometers. And let's say the entire time taken was 7 hours. So our speed would have been 25 by 7 kilometer per hour. But velocity is 0 by 7 kilometers per hour, or 0. So this is a very basic difference between speed and velocity. Now why do we need speed and velocity? Because none of these mathematical quantities are there without a reason. So let's say if we know that a car had been traveling in a particular direction and it has to cover 180 kilometers in terms of the actual road distance, not the displacement, actual road distance. If this is our target, to cover 180 kilometers, and in first 1 hour we have traveled 20 kilometers. So 20 kilometers in 1 hour. So another way of saying this is my speed is 20 kilometers per hour. So we need to figure out, or we need to predict how much time it is going to take for us to cover the entire journey. So if 20 kilometers per hour is our current speed, and given current known circumstances, we plan to maintain a steady speed and stay somewhere around 20 kilometers per hour. So our overall journey will be of 9 hours. So that's a educated guess, provided that our driving conditions and other stuff do not change much during the rest of the 160 kilometers of our travel path, which is still remaining for us to cover. So speed basically gives us an idea about, it's kinds of a prediction of where we are going to be after a certain amount of time. Now what about velocity? Velocity is a very similar thing. It's just that there is a direction associated towards it. So let's say we are here, and at certain moment we are heading towards this direction. So let's say A, B, C, D, E, F, G. So at a certain point of time, if AF is where our car is heading towards, and if we plan to maintain a steady velocity, when we say steady velocity, the word steady with velocity stabilizes two things. One is that we are going to cover the distance in a similar manner, on a similar rate. So per hour, let's say 20 kilometers per hour, and in the same direction. So we'll continue on the AF direction and we'll reach somewhere on this line. Now if we know how much or how many hours we are going to travel, we can predict that we'll reach a point G after certain T amount of time, T hours of time. So it's not just talking about AG distance, it is talking about a direction A to G. So on the graph it will tell us at which point we will be after time t. Speed does not give you the sense of direction. It does not tell you on a graph chart where your point will be, where will you land after 9 hours. You will be somewhere at a distance of 180 kilometers from your initial beginning point, but it does not tell you where you will be. So to pinpoint your location, you need the sense of direction, and velocity provides us that. Let's say a particular object is moving at a variable speed. So from 0 till 1, 2, 3, 4, 5. So I'm marking for 5 hours, 5 different points. From 0 to 1, this first hour, it has moved with a velocity of 20 kilometers per hour. From 1 to 2, in the second hour, it has moved with a velocity of 30 kilometers per hour. And so on. I'm just writing down the other 1 hour duration of values here. And in the 4th to 5th, which is the last 1 hour, it has moved to 50 kilometers per hour. So if somebody wants to know what is the average, let's say these are all speeds, let's not confuse with the direction at this point of time. If somebody asks that what is the average speed of the vehicle during this time, the moment such a question arises, always remember that average always has a base point. So if somebody asking for an average speed, it has to be specified that for what duration. Is it from this 5 hours? Okay, so if this is for 5 hours, let's say what is the average speed during the 5-hour journey. What we need to do is that we need to add all these speeds together, 20 plus 30 plus 20 plus 30 plus 50, which is like 50, 50, 100 plus 50, 150. Now how did we arrive at that? In fact, since these are all 1 hour intervals and the speed was 20 kilometers per hour, 30 kilometers per hour and so on. So this was a speed chart. If we draw a distance chart here with the same marker 0, 1, 2, 3, 4, 5, 20 kilometers per hour for 1 hour. So it has traveled for 20 kilometers. 1 to 2, 30, 20, 30 and 50. So total distance covered is 150 kilometers divided by total time taken 5 hours. So that's how you find the average speed of journey. Similar to that, if somebody asks you what is the average speed between 2 to 4 hour mark. So between 2 to 4 hour mark, you have covered 50 kilometers, 20 plus 30, 50 kilometers. So average speed during that will be 50 kilometers by, what is the time taken? 1 hour and 1 hour. So total 2 hours. That is 25 kilometers per hour. Now you can see what is the difference. The overall average speed and the average speed between a certain portion of the journey. So average speed always comes with a base pointer. So your average speed from where to where. Unless specified, average speed is always from beginning to the end of journey. I'll repeat, unless specified. If the question does not specify what is the average speed between so and so points or between so and so time, if it does not simply ask what is the average speed of the vehicle, then it is pointing towards the average speed during the entire journey. So this entire 5 hours time period. So far we have spoken only about uniform motion. Yeah, and then in last example we did talk a little bit about non-uniform motion also, since we spoke about variable speed, but we never spoken about how the speed changes. Now that brings us to our next topic, acceleration. So what is acceleration? Acceleration is a rate of change of velocity. Rate of change of velocity. So that means velocity if initially the velocity of a vehicle was v2, if initially it was v1 and finally it was v2, and the time taken from changing to v2 to between v2 and v1 is t, then acceleration a is denoted as v2 minus v1 divided by t. For a practical example, let's say a vehicle started with the initial velocity of 20 kmph. After 1 hour, the velocity has changed to 100 kmph. So what is the acceleration? If it has uniformly accelerated from 20 to 100 during this entire 1 hour period, we can find acceleration as 100 minus 20 divided by 1. Now what will be the unit of such a mathematical quantity? 100 and 20, these are all kmph. This one is h. So this is 100 minus 20, 80 by 1, which remains as 80, and kmph divided by h one more time. So it is kilometer per hour square. kmph anyway had a km divided by h, and there is another division by h. So it's km divided by h square. Or in another way, in a different unit, a can be meter per second square. Either we write it like this or we write it like this, s to the power minus 2. Similar to that, km h to the power minus 2. This concept is a little bit hard to understand right now, but when we reach the exponents chapter, we will talk more about it. Now, what does this mean on a distance time chart? Let's say this is the time axis, this is the, you can either plot velocity here or you can plot speed here. Let's say it's a speed versus time axis. If a vehicle is moving at a steady speed of 20 kilometers per hour, then we can plot this. Let's say this is 10, this is 20, this is 30, this is 40. So at any given time, so time 1 hour, 2 hour, 3 hour, 4 hour, 5, 6 and so on. This is 0 point, or the origin. 20 kilometers per hour means this is the point. So at 0th time, at the initial beginning of the journey, it is 20 kilometers per hour. After 1 hour, it is still 20 kilometers per hour. After 2 hours, it is still 20 kilometers per hour, and so on. So at any given point of time, the speed is 20 kilometers per hour. So if you connect all those lines, this gives you a straight line parallel to the time axis, because your velocity is not, this velocity or speed, it is not changing. So let's say I am interested at what happened between 0 and 6 hours. So I will close this with an imaginary vertical line. Forget the chart for a moment. Let's say what was the distance covered if you were asked this question. What was the distance covered in 6 hours? How will you find that out? You know the distance equal to, or rather, you knew that speed equals to distance by time. That means distance equal to speed multiplied by time. Speed was 20 kilometer per hour multiplied by 6 hours. That means 120 kilometer. So now you know the value of the distance, how much it is. Now let's look back at the graph. If I shade this entire region, and then pick it out and draw it separately. So here I have a rectangle starting at origin point. Let's say OABC. This height is 20 kilometers per hour. This spread is 6 hours. So what is the area of the rectangle, this entire shaded region? What is the area? The area of this rectangle is length multiplied by breadth. That is OA multiplied by OC. 6 into 20 equals to, which amounts to the same result we found from the D equals to S multiplied by T formula. So in the distance time graph, if you plot the speed, so this is your speed plot. This line was your speed plot. If you plot the speed and then find the area enclosed between the speed plot and the time axis for a given amount of time, the area of that enclosed figure is your distance covered. So if I provide you another chart here, this is the time axis, this is the speed axis. From O, see, this was the initial point. After certain time A, if we plot the speed has come to something like this, B. As you can see, C and B are at two different heights. Clearly, what I am showing here is a change in speed or change in velocity, whichever you say. It's a change in speed. I am just talking of the magnitude here. And if I have assumed that from C to B the change has happened in a gradual uniform way, the speed graph will look something like this. So from C to B, or from the time 0 to A, what is the distance covered? The distance covered will be, I'll repeat the definition again. The distance covered will be the area enclosed between the time axis and the speed chart for a particular amount of time. So that means OABC, this entire area. Now I will show you later how to calculate this, the area of this quadrilateral. But remember that C to B, you're seeing a slope here. So if I try to draw a parallel line to the time axis, this becomes a 90-degree angle. You are seeing a slope here, you are seeing a gradual inclination. This is due to the acceleration. So your acceleration here, A, is final velocity AB, initial velocity OC, so V2 minus V1, AB minus OC, divided by time taken, OA. This will be your acceleration found from the distance time chart. Now, let's say this is T. We denote AB as V. We denote OC as U. Then what we find is a quadrilateral that looks like this. This is T. This is U, this is V, there is a gradual change, so O, A, B, C. If I want to figure out what is the distance covered between this entire time, for easier calculation, let me drop a perpendicular here and divide this geometric figure into two different parts. One which is a rectangle, Let's say this point is D. So now we find a rectangle OADC and a triangle CDB. So right now we have a triangle CDB and a rectangle OADC. OADC, the sides are U and T. So what is the area of this triangle? UT. Area of this rectangle is UT. What is the area of this triangle? CD is T. You need to figure out what is BD. BD is the change of speed. So BD is a change of speed, and we know that acceleration A equals to, or change of velocity here, divided by time. So the height of this triangle H is the change of velocity, change of speed. T is the time. So A equals to H by T. That means H equals to AT. If you know the height, how do you find the area of the triangle? Area of the triangle is half into base into altitude, which is half T AT. That is half AT square. So with this, now we know what is the area of the triangle. We know what is the area of the rectangle. So what is the overall area? Overall area OABC. The area is UT plus half AT square. So the distance traveled is UT plus half AT square. Remember that we will push that into our bucket of formulas later. This is one of the very important formulas regarding motion that we need to memorize and keep in mind. Let us write down the formulas of motion. The first formula will be V equals to U plus AT. Second one will be S equals to UT plus half AT square. And the third one, 2AS equals to V square minus U square. We have already proven formula 1 and 2. The second formula had been proven in the distance time graph. The first formula is directly derived from the definition of acceleration. So let me just give a quick recap. So acceleration was defined as V minus U, final velocity minus initial velocity divided by the time it has taken to change from U to V. That implies AT equals to V minus U. That implies V equals to U plus AT. I have jumped a couple of mathematical steps in between. If this is not clear, just do let me know. I'll explain that more in the comments. So that provides our first formula. Second one was derived from a distance time graph OCA velocity b, finding the distance between C and B points have been done by dividing this into a rectangle and a triangle and then figuring out what is the overall area. So which has led us to S equals to ut plus half at square. Please refer to the earlier part of this video to see how the derivations were done. Now the third formula, 2as equals to v square minus u square, is more of a time elimination between 1 and 2. The second and the first formula gives you the last one. So let us prove if 2as is v square minus u square. So v square minus u square is equal to u plus at whole square minus u square equals to u square plus 2 aut plus a square t square minus u square equals to a into ut plus half a t square 2a into s. Hence proved that 2as equals to v square minus u square. So this leads to our third formula. So these three are very important formulas that you need to remember for solving motion related problems.